All right, good morning, everyone, and welcome to another Security Compass webinar. Today's webinar will be on research perspectives on lightweight security risk assessments. Thank you for joining us today. My name is Raquel Rodriguez, the events manager here at Security Compass and your host for today's webinar. Before we get started with the actual content, I'd like to just give you a quick overview of Security Compass. For those of you who may not be aware of us until today, Security Compass was founded in 2004 and began with a team of experienced penetration testers. Today, we have come far and work with many large enterprises globally to manage their cybersecurity risks through balanced development automation. We have three key offerings. Our flagship product, SD Elements, enables organizations to deliver software quickly and reduce costs through automation. Our modular role-based e-learning solutions empower organizations to embrace DevSecOps, and our strategic advisory services offer expertise in cloud security, pen testing, and red teaming for a better security posture. Let's quickly go through some housekeeping items. As you might notice, you've all entered the session on mute to reduce background noise. Second, a recording of this webinar will be available after today's event, and you'll receive an email with a link to that recording. We will also be publishing this recording in the resources section of our website. Also, we encourage everyone to raise questions. Please submit your questions into the Q&A chat and we'll address them during our Q&A session. If after our session you'd like to follow up with us or you have a topic you'd like to see covered in a future session, please email us at contact@securitycompass.com. Like I mentioned, for today's webinar, we're going to focus on research perspectives on lightweight security risk assessments. I'm pleased to have here with me today Altaz Villani, Christopher Schmitz, Sebastian Pape, Simone Curzi, and Hassan Yasser. Gentlemen, thank you for being here with me today. I know our audience is keen to hear your presentation, so I'll let you take it from here.
Great. Thank you very much, Raquel. Appreciate that. And I think it makes sense maybe at the start of this conversation here today, if we could just go around the table and have everybody introduce yourselves, tell us a little bit about what you do, and just so that our audience is familiar with you as well. So I'll start with you, Christopher.
Yeah, first of all, thanks for inviting me. I'm a research and teaching assistant at the Goethe University in Frankfurt in Germany. And I'm a last year PhD student. My PhD is about lightweight decision-making in information security. And it primarily deals with questions like how to measure information security in an efficient way, or also how to identify optimal security measures, especially focus on small and medium-sized enterprises who often do not have much security know-how and security-related data.
Great. Thank you. Sebastian?
Hello, everyone. Thanks for inviting me. I'm also from Goethe University. I'm a senior researcher there. I have a mathematical and cryptographic background, but recently my interest steered more towards how can I support the user best to take informed decision, which goes pretty much in line what Christopher has just said, but I try to shapes this area more from a user perspective and see how users can be supported.
Great, good to have you both here. And then on the industry side, we've got a couple of people as well. So I'll start with Simone, if you can give a brief introduction to yourself.
Hi to everyone, and thank you, Altaz. I'm Simone Curzi, Principal Consultant from Microsoft Services, and I'm an application security expert, threat modeling expert, and I collaborate with Altaz and a lot of other colleagues in the field to improve how we do security. So that's me.
Wonderful. Glad to have you. And Hassan?
Hi, everyone. Thanks for having me, Altaz. I'm Hassan Yasser. I'm a technical director at the Carnegie Mellon University. My expertise is working with DevSecOps, DevOps, and also I'm a adjunct faculty member teaching software security and DevOps at the CMU Carnegie Mellon at the graduate level. So I'm a practitioner person. I would like to really apply the all security measurement throughout the software delivery lifecycle, which I believe it should be. And I'm helping organizations and also researching how it can be done, what our effective methods are, how can we apply the software security into the lifecycle.
Wonderful. So it's glad to have, just really good to have all of you here today. We're hoping to have an engaging discussion where we'll have people on the academic side, people on the industry and practitioner side. And so we should have some interesting discussion. Just a note to the audience, if you've got any questions, please feel free, put them in chat, put them in Q&A. We'll be happy to take these questions as they come in. And at the start of this conversation, I think it would make sense, Christopher, why don't you share a little bit, for you and Sebastian, share a little bit about what you're seeing from the research that you've been doing thus far.
I hope you can see my screen now.
Mm-hmm.
Okay, perfect. Yeah, I'd like to present to you our ongoing research on lightweight security risk assessment, which basically is based on attack trees. And for this, I'd like to briefly introduce you to the concept of attack trees. For those of you who are not familiar with attack trees. What are attack trees? Attack trees are a structured representation of attack scenarios where an overall attack goal is decomposed into many intermediate steps using and or operations. And an example here is the overall attack goal: steal the server. Possible intermediate attack steps could be to get access to the server room, and to go out unobserved. And we see here is an and, so both of the attack steps have to be performed. And on the next level, we could say, okay, how can we get access to the server room? One option could be to break down the door, or to get the key with social engineering. And in this case, you see there is no AND operation. And if there's no AND operation, this means there is an OR operation. So an attacker has two options, and he can decide whether to perform the one attack step or another attack step. But it is also possible to extend the concept of attack trees with defense measures. And this helps us to get so-called attack defense trees. And the idea here is that we identify possible countermeasures for each of the attack steps. And for example, for the attack step B, get the key with social engineering, here we could perform some awareness or training measures. And to protect against the attack step break down the door, we could secure offices, rooms, and facilities. And attack defense trees are very strong because they map the attack perspective with the defense perspective. And this helps us to get an integrated view and an integrated understanding of to which degree our implemented defense measures can help to protect against specific attack paths and attacker behavior. And this also helps us to quantify the security or risk level of entire organizations or of specific components or modules. And for this, we can quantify, we can make quantifications with these attack trees. And how can we do this? We can just apply, or we can annotate attack metrics to the different attack steps in the attack perspective. For example, we can say break down the door takes very much time, or how costful it is, or the required resources. And these metrics that are annotated to the leaf nodes are then propagated up the tree. This can be done using these AND and OR operations. And this helps us to get an understanding how costful or how much time the entire attack scenario takes. And the same can be done for the defense perspective. For example, I think the most important thing is the implementation status, that we get an understanding how mature the specific defense measures are. And in literature, there were many approaches that help us to quantify the overall security and also the overall risk level based on these information. But I think now from a practical perspective, the big question is that we also want to discuss today is how can we construct attack trees in practice? And there are several options. Of course, you could completely manually construct those attack trees, but from a scalability perspective and also from some other perspectives, it might be difficult. And therefore, we've decided to use the master attack methodology. And the general idea of this master attack methodology is that level 0 of an attack tree just represents the attack goal, and all the following levels represent different kind of information. For example, level 1 describes when a specific attack step takes place, level 2 where it takes place, and level 3 what an attacker actually does. And maybe we can have a look how this can look like, and to make it more concrete and less abstract. Here we have the overall attack goal exfiltrate data. On the next level, we go through the so-called kill chain component, which basically describes the life cycle phases of an attack step, starting with reconnaissance, weaponize, deliver, exploit, and so on. In practice, the reconnaissance and the weaponize phase are probably the most important ones, that one identifies and understands the targets, what can we understand and how, what can we attack and how can we attack it. Weaponize means that we, for example, construct cross-site scripting commands or malware that we then deliver and exploit and so on. And of course, not each of these phases are necessarily relevant for every attack. I think this is important to mention. And in the next step, we can we go through the surface areas. And this is what we do for each of these phases. For each of these phases, for example, for the reconnaissance phase, we systematically go through all the potentially attackable areas. For example, in web application, this could be the session management, authentication, authorization, and so on. And yeah, and once we've done this, we go more deeper and have a look at the CARPAC and attack matrix. What is CARPAC and attack matrix? These are just databases for attack step enumerations. An example, for example, is the CARPAC entry 94, which describes man-in-the-middle attacks. And it also systematically provides information like likelihood, typical severity, but also the relationship characteristics. And based on these relationship characteristics, for example, parent off, can follow, and something like this, we are able to automatically construct those hierarchies, and those hierarchies can later be used to automatically construct attack trees, but I will tell you more about this later. But I think the interesting thing is that both databases, CARPAC and attack matrix, which represent different kind of abstraction levels, can be mapped with each other. That means the CARPAC entry man-in-the-middle attack also has, there is a direct link in the database to the corresponding attack matrix entry. Yeah, and now we can go one step deeper to the CWE. So I think this is even more known and more of you will be familiar to this concept of the common weakness enumerations, this database. And each of these entries is also, there is also a mapping between these CWE entries and the CARPAC entries. And now the question is how and to which degree these master attack methodology help us to construct attack trees. I think the first levels are very easy, less complex, and you can easily completely manually construct it because there are not too many options, and this is what you can do with in not too much time. But where it gets more complex are the CARPAC attack matrix and CWEs. As you can see here with only this picture, it can be really difficult. And one option how we could make use of these attack hierarchies is that one systematically goes through this hierarchy on a following a top-down approach, and then you manually select these automatically constructed subtrees. I think we can have a closer look by the following use case scenario, because we also wanted to understand this is a theoretical concept, to which degree can one also transform this concept into practice. And for this, we started with the use case scenario of obtain a session ID. And here we want to have a closer look on level 3 to 5, because this is something that cannot easily be done completely manual. And the question is, to which degree can this be automated? And in the MITRE attack database, there were 2 relevant attack steps that are relevant for this overall attack goal. Because yeah, it's steal web session cookie and network sniffing. And as I said before, in this MITRE attack database, there is a direct link to the corresponding CAPEC entry. That means we can look at this entry, and it refers to CAPEC 21, CAPEC 242, and 2158. And as I said, in the CAPEC database, there were so-called child-off relationships. And these child-off relationships is exactly what you see here, what is represented as OR representation, with OR operations. And you can see there are 2 options to see the web session cookie, either by code injection or by exploitation of trusted credentials. And on the other hand, sniffing network traffic is also an option, because if you transfer web session cookies in an unencrypted way, you can also sniff the content of the session, of the cookie. And that means this hierarchy is constructed completely automatically. And then we can have a closer look at the leaf nodes. And these leaf nodes, again, can be mapped to the CWEs. I think the details which CWEs are listed here are not relevant. The relevant thing is that most of the entries, the CAPEC entries, can be mapped to the CWEs. And that means now you see that there is a relatively complex attack tree that we could completely automatically generate by using the information from 3 different databases. And now the question is, can we use this in practice? Probably not, in how you can see it here, because there is a lack of contextualization. Because, for example, we don't know if we really have, we have not checked if we have a database server or something like this. And then the idea is that the security analyst systematically goes through this tree from top to down, and then he manually decides to which degree the respective trees or subtrees are relevant for the use case. And for example, it could be the case that he says, okay, network sniffing is not relevant for my specific use case, and that means this subtree is eliminated. And then he goes through the next, has a look at the next level. Then he says, okay, both of the subtrees are relevant. Then he goes through the next level and he says, choosing message identifier might not be relevant for my use case, so we eliminate it. And furthermore, of course, it can also be the case that one decides that this attack tree is too complex. So maybe we want to merge these different kind of cross-site scripting attacks because there is no additional benefit from this. and we merge it, and so it gets less complex. So the idea is to automatically create such an attack tree, and an attack and security analyst systematically goes through the tree and finds it. And maybe some concluding words, and I think then we can open the discussion, is that in information security risk assessment, there's always a trade-off between precision of the results and the required effort know-how on the other hand. Because if we want to have very precise information, of course, then we would have to have a very precise model on which servers we have, or what is the server topology, and which software is installed there. And on the other hand, we can also, and this is what we oftentimes do with attack trees, we have a higher abstraction level, because maybe the customer only wants to have a quick self-assessment, wants to have a first understanding of the security or the risk level. And of course, there are several options also to somehow resolve this trade-off. One option is pruning techniques. For example, one could ask the security analyst before whether there is a database service, a database server in the infrastructure. And if there is no database server, then we would prune all the SQL injections and all the specific attacks that refer to database servers. And interestingly, if we go back, each of these CAPEC items and also the CWE items in the databases are also associated with infrastructural characteristics, like like the required infrastructural characteristics, like database server, and also many other characteristics that we could use for an automatic, semi-automatic pruning. Another option would be to construct construct domain-specific attack trees, for example, for the energy sector, or for web applications. One could model the OWASP top 10 and probably also some more. And one could also differentiate between different infrastructure classes in web application attack. Maybe one could differentiate between 2-tier and 3-tier architectures, and then one could ask the security analyst if he wants to model a 2-tier or a 3-tier architecture, and that means everything goes into somehow construction support. Yeah, I think this is was a very brief description of what we've did so far. But of course, this is ongoing research, so we would be very thankful for the results of the discussion, which will follow directly now.
Wonderful, that's great. Thank you very much, Christopher, for sharing some of your research. What I'd like to do is now we can take a look and see what an industry perspective to this might be as well. If you can just stop sharing your screen, let me bring up a whiteboard here, and we can continue this dialogue and have this kind of a discussion. What I'd like to do is I'd like to kind of pose this question to Simone. So there are so many things that Christopher had shared, right? We're looking at things, for example, around CAPEC. We had seen some things that he had shared around CWEs. We have seen some stuff around risk, and there's some additional things there around architecture. And we also saw, you know, that context is going to be a really important thing. How do we make this contextual for the environment that we're in? And then we also took a look at some additional libraries when we look at CAPEC and CWEs, but we also saw some things there around MITRE, sort of the attack framework that MITRE has. But I wanted to just pause for a moment And Simone, you've got a lot of experience from a threat modeling perspective. You understand attack scenarios. You know, talk a little bit about the industry perspective on trying to work with all of these various concepts and how they might in fact come together in some way.
Thank you, Altas. Absolutely. Those concepts are extremely important, and having a good understanding of those aspects provide a lot of value to any assessment of security for a solution. The importance of those databases is, first of all, because they provide a framework that is recognized by the industry and allow to align and link together different concepts in a very recognizable and respected way. The importance of those databases is also about aligning the different risks, the different weaknesses with experience, with actual weaknesses, with actual vulnerabilities that we find in products. For example, I would add to those databases CVE also, because this is another Mitre database that is highly aligned with all those. And in fact, if you go and look, for example, to CWE, to the weakness enumeration, you can see examples of vulnerabilities, and vice versa. From the vulnerabilities in products, you can go to weaknesses. So this approach is definitely very important, and I concur totally about the fact that it is precious to get to demonstrate the relevancy of the different findings that you have in a threat model experience. Mm-hmm. But I would want to spend a couple of words related to the threat modeling experience as it is, and the difficulties that we are facing right now. What I've seen in many cases is that the threat modeling can be a relatively complex activity in which, first of all, you have to understand the system, and then you need to identify the different problems on the system, and finally the mitigations. And in some way, we have seen that still this approach is relevant even for the proposed approach by Christopher. In fact, we have started the identification of the attack tree bottom up, starting from the vulnerabilities that are present in the system, represented through the weakness representation, the CWE, and then we can go down identifying the different elements. Now, in our experience, what we see is that typically a system that you analyze can be quite a complex beast, can be composed of dozens of different elements. Some of are external, some are internal. And it's very normal to work with the systems that are composed of around 30, 40, or even 50 different components. And that's without going too much in depth, because you can go much more granular than that. If you have this sort of analysis and you have a respectful knowledge base that you can use, you can get from this set of from this system, you can identify something in the order of hundreds of different instances of issues, taken typically from a list that is around 30, 40, or again, even 50 different categories of issues possible. So we have quite a number of different threats identified. And each of those threats really should be contextualized, still needs to be really contextualized, because it may happen, yes, on a specific component or a specific subset of the system, and that's true. So you have some part of the context. But what you need also to identify is the population, the malicious actor that could perform that attack, and also the intent. All those elements concur in determining the potential damage that you can have. And the truth is that for each of those threats, you don't have a single scenario. You can have dozens. So the number started to become huge, thousands of different scenarios. And each of those scenarios would essentially represent a single tree in the attack tree. So the whole tree, okay? What we have seen, what Christopher has shown to us, the big tree that we have seen in the bottom right of one of those slides that was real and manageable as it was complex, that will be repeated thousands of times for each threat model. Now, we have already the problem of unmanageability of those threat models. So that actually the adoption of templates to generate automatically the list of different threats has demonstrated more than once to provide, in a way, low quality threat models. And low quality means not so useful. So my point of view is that we need to use this approach, which is precious. Again, it's very important in a slightly different way. I don't think that this is an option really to perform the analysis of a system. But this is a great way to understand the importance of a threat that you have already identified, because it creates information about when, if the problem is known, if it is recognized, what are its characteristics, when this problem was seen. In fact, the attack database contains also examples of known systems, of known instances of this sort of attacks. The same goes with, in some cases, it's a little less frequent with the KPEC. So you have this sort of background that is provided by those databases. And so relevancy is extremely important as a consequence. Another idea that we could use this system for is to get a better understanding of multiple weaknesses, because a lot of attacks that we see nowadays do not really leverage a single weakness. They leverage multiple weaknesses, and perhaps we are not doing a very good job right now in analyzing all those different weaknesses together to understand what are complex attacks that may occur. Right now, the exercise is more related to analyze the single weakness. Okay, we are having a weak management of the session. We address this issue because that could mean that someone could steal the session. But what if this weak session could be aligned, for example, to some weak protection of some storage? Then perhaps combined, you can do more things. You can have more complex scenarios. Or what if you don't have, for example, very classical example, you have a weak protection against the denial of service. Then you may have an attacker that is extremely noisy, and you go focused on that, and then the same attacker compromise your system, attacking your goods, because you didn't consider that those things could come at the same time. So the monitoring that you put in place to protect your storage, your data, was not so strong to provide you the context for this specific scenario. So this is essentially my point. And just to conclude, I really think that we have various type of roles, various type of capabilities working with threat model. Right now, we are having very big issues with ensuring that the people that are not expert for doing threat models can approach this practice. The type of experience that I've seen by using typically automated tools are relatively poor. Nothing that cannot be achieved with simply some good checklist. So I think we should focus a little more in helping this sort of roles in getting quality results.
Yeah, and so we end up now expanding the role of threat modeling from being just a technical initiative to, or set of activities, to something that might include some other people as well, which brings us now, I'd like to pull in Hassan into this conversation. Hassan, you've done a lot of stuff in the DevOps space. So given everything you've heard, talk a little bit about your perspective on the integration of DevOps, which has pipelines, automation, and threat modeling, right? So we've got these databases that exist out there. We're dealing with architecture, risk in a certain context. What are you seeing out there?
Thanks, Altaz. And a couple things to edit what Simone said. And I'm going to start with the architectural pieces. Actually, he pointed out a great, because we are building up very complex systems. When we have complex system like 30, 50 components of each of the systems has some vulnerabilities in it or the design wise. So the biggest problem, what I have been saying in the community is, we go fast as what the DevOps is saying it. We would like to deliver fast. We always relying on the tooling perspective. And we are saying tool is going to do the great job, like analyzing static analysis or dynamic analysis of the code. But big problem for me as that community is, as a developers, we don't know what vulnerabilities we have to address it. It is what the tool is saying to us. There's a disconnect between the knowledge pieces that we are building as an attack tree or threat modeling. There is a disconnect between that knowledge as a useful format in developer-centric. The two reasons is I see that one is, as a knowledge we are sharing, it is not a digestible format with the developers. The second is developer, they don't know which one is relevant to a specific attacks. Like such as like we're looking for SQL injection, one big example. Now we are asking the developer to implement the CWEs. Great, CWEs they have to implement for what? Like what is the purpose of that implementation CWEs? So tools are saying there is a vulnerable in your code as a developers. Here is a CWE, you have to fix it. Now the big challenge is it really related to my knowledge, my system that I'm building? That goes back to architectures. And then that goes back to the domain knowledge that Christopher and Simona said. So which one is related to us? Which one I am going to spend the time of fixing the CWEs? And sometimes using a multiple static analysis tools are creating a conflicted message, getting a multiple CWEs. So what is the right one has to be fixed? What is the importance? What is the level of the urgencies and risks? So I said there is a definite disconnect between the DevOps tool perspective to the knowledge pieces that has to be resolved. Another element I would like to call out, and it's like Simone brought too, is CVEs. So in the community of the DevOps concept, we are using so much dependencies, so much libraries. Now we need to know which libraries has a CVEs in it. What is the relevant CVEs that I'm using in a component in my build-up automations of the, the infrastructure pieces, or Dockerizing some other deployments, or using Kubernetes, whatever the tools and techniques I'm using, it's specifically tool-centric. What CVEs are aware of it in the specific libraries? What is the related to the attack trees that I will develop that? And what is the threat may come from that CVEs? Again, that goes back to the relevancies. So let's say if I'm using a one container deployment, I use the container analysis tools and listing all the CVEs. Which one is related to my attack trace? What is the level of that information I have to address it? What is the impact to my systems? That knowledge is not known by the developers.
Mm-hmm.
And then developers need to know why I'm doing it. Well, right now, the most of developers in the DevOps communities, they're looking for what needs to be done. But this knowledge will help the developer why it needs to be done. Remember that. And then I'm teaching the class at the CMU. I see many examples. Most of the CS students, they are not knowledgeable enough to security. They are not trained like that. They are not trained to understand the knowledge because security is a living thing. It's changing. But we are expecting as an implementation for a developer level, we are expecting developers should do everything, but they don't have a knowledge on it. This information, attack trace, and then information lightweight concept will help to gain the knowledge in a domain specific and language specific and technique specific.
Yeah, that's interesting. And so the gap that exists now kind of makes them rely on the tools that are there, but the tools themselves are missing relevant and contextual information. And so we end up in this spiral where we are trying to go in and ultimately, from a threat modeling perspective, focus on this whole concept of risk. How do we minimize the risk? But defining what that means in terms of training, in terms of understanding the business value, things like that begin to enter into this, and it becomes kind of a challenge at this point. So let me turn over. So Christopher and Sebastian, let me ask you a question. In the research work that you've been doing, has this idea of business risk ever come up? I know that you're doing research on lightweight risk assessment, but I'd like to dig a little bit deeper into risk, and what specifically are you seeing from a research standpoint when it comes to risk? What's the definition?
Yeah, I think risk is of central relevance also for our work, because on the one hand, you have security assessment, and on the other hand, you have security risk assessment. And the standard definition of risk is the probability of impact and the magnitude of impact. And for example, the structure of attack trees, which basically represents the number of attack paths that are in the system, and the degree to which the security, the implemented measures protect against these attack paths. They can be used to derive the probability of impact. And in general, the idea is that the overall attack goal, the root node, is associated with a risk or a business risk, and this helps us in the end also to prioritize, in this case, to prioritize the weaknesses with regard to their overall business risk. For example, if we see that one specific CWE is relevant for many, many attack paths, and maybe we do not have a proper protection against these attack paths, then and furthermore, if these attack paths are can cause high impact, then the corresponding CWEs might be much more relevant than others. That because even CWE is relevant only for one attack path that can cause maybe medium or little impact, then this gives you an indication of on which CWEs you should focus.
Yeah, and kind of focuses based on what the priorities are. So Simona, let me ask you a question. We have this idea of impact and magnitude. And, there are two schools of thought. We've got a qualitative approach and we've got a quantitative approach. What are your thoughts? What are you seeing when it comes to identifying risk?
Thank you for asking. Yes. Historically, my company comes from a qualitative approach represented as quantitative, which may be confusing, and it is. If you think to something like dread, that was really a dreadful approach. It was about essentially it was complication over the approach of identifying probability and impact, and then to come up with some totally random number, multiplying them in a very imaginative way. So do a lot of work, do that multiple times to come with the result that is totally random. And that's the severity of the issue. So the goal, by any mean, this has been fortunately deprecated since long, and now nobody uses it anymore. Still, the approach that we use is qualitative, and that's a pity. Qualitative means that you identify a category for the severity. We do not use anymore probability multiplied for impact, because essentially it is still a bad way to do that. It's still requiring to do some job on two numbers identified by the good and then multiplied together. You will have an error, you multiply errors, and guess what? You have a bigger error. So why to use that? What we use is another approach, which is called bug bar. Bug bar is qualitative. It's based on the identification of different severity levels. Each severity level has a description. And then you identify for each one of the threats that you have, in what level you fall. If it is critical, then you have something that interests a major feature in a very important way, and there is essentially no mitigation for that. It's very big. So it's the typical situation in which you will not want to go in production. And you do that for the high severity, medium, and so on. It's qualitative, so still there is a lot of space for mistakes. What you have in a certain, you feel will be high, for someone else will be medium. So there is a lot of space for discussion, perhaps not much value, because at the end of the day, if I tell you that something is medium severity, would that really mean that you needed to invest $1 million for a mitigation? Who knows, right? So it's not that informative. There are ways to address also the possibility of coming up with biased results, because of course with the qualitative analysis, with qualitative estimation, bias is a reality. Like for example, we use an approach based on stride to identify what really matters in the specific context, but still the problem is there. So quantitative is definitely a much better approach. And the best approach we have identified so far is represented by FAIR, F-A-I-R, which is standardized by the Open Group under the name Open FAIR. And it's a very interesting approach. We like that a lot, but it has a problem. And the problem is that it takes some time to analyze a scenario. And as discussed before, you may have thousands of different scenarios inside the threat model. And nowadays, the problem is to make sure that the analysis that you do with the threat model makes sense from a perspective. So if you have a project and you do a threat model that lasts more than the project itself, what is the gain, right?
Yeah.
So you need really to be conservative with the cost, and you need to be sure that the impact that you have for security is reasonable. And for this reason, something like FAIR that would require to spend something in the order of half a day or 1 day to analyze a single scenario, or even more if you are just starting, that will simply not be usable in that context.
Mm-hmm. That's great. And Hassan, let me turn over to you now, and I'd like to get your perspective for DevOps teams that are moving forward at this point. Help us understand, how do you get risk into a DevOps pipeline? Like, how do you do? Is there qualitative way, quantitative ways of doing it? Are you seeing certain trends, certain patterns that people are using to make sure that we are continually addressing the risk concerns and not introducing additional risk as we go through the pipelines?
So the main things what I see right now effectively, the organizations are tying to the CWCVs as a result of study analysis and seeing to the what is the risk they have to address in the context of any features that they're developing. Let's say I have a one issues I'm working on it, what the risk associated for that issues is relevant. So the risk management teams or the security team are identifying potential security elements and then controls in that specific features, then what CWs or CVs has to be addressed on a specific context of it, then automatically and tying into the DevOps pipeline using basically static analysis tools and creating a report that goes back to the result to the risk assessment tools, and then giving a more quantitative way to the users or developers, meaning the architects, are assessing risk properly for based on the static analysis. I see a lot of effectiveness, but the biggest challenges in here, as I said, we would like to be more proactively. So this concept will help to the architects and developer or DevOps team or a product team to build up effectively what needs to be done and try to understand the possible attacks may happen, create a proper risk assessments in the context of creating issues and features, and list all the potential CVs, CCWs, like basically starting from bottom up on attack trees, put into our tools and techniques that we're using in the automated fashions, and then answer the question why I'm going to use, what's the purpose, what is the risk I'm eliminating for that work. So I see something is started and it's effectiveness, but it takes time to develop that context because that goes back to the knowledge pieces I'll test.
Yeah.
So we're not expecting the architects or the developer will define risk by themselves. We're expecting the threat modeler or the security expert are creating that knowledge and sharing in a format then architects can use it effectively or developing it effectively. So I saw many examples in many programs in bigger applications with a great concept of creating a threat model. We get a great work attack trace. How much is useful? How much we can translate that knowledge into the a new regime of automations and then incremental phases and integrations. And also another things I would like to call out, and Simone said a good point, we may have many use cases, like hundreds of use cases. Actually, all these use cases or the exercise scenarios will help us to create a nice security testings. Now we are adding a testing regime and testing thinking. What type of test cases we have to create it? What type of scenarios we have to run it? What type of things we have to automate that? So now we have to generate that test cases based on the attack trace that we have done it, and we know the scenarios. And develop that knowledge as soon as when we attack trace. So we have to work together with the people and defining that scenarios, creating a nice testing frame so we know what we are doing and we can implement it properly. Because otherwise it goes back to the relying on just a few tools, and then we are saying we are
Hi, Hassan, are you there? Looks like we just went quiet for a bit.
So
Okay.
I guess something happened to my internet, probably got dropped out. Can you hear me now?
Yeah, I can hear you loud and clear. That's great. I just have, I think, a time for one more quick question, Hassan, to you. Um, this becomes a challenge when we talk about risk and we're looking at pipeline of pipelines kinds of models, right? We have to make sure we've got consistency now between definitions of what we mean by risk so that we can effectively roll this up to make informed decisions, because this automated pipelines are starting to, we're starting to add more and more intelligence to them. We can extract information from them. We're starting to come up with thresholds for risk and things like that. So are you seeing that there's at least some discussion happening on trying to clearly identify common vocabulary around risk when it comes to DevOps pipelines and scaling the pipeline of pipelines kinds of models?
So I see two elements. One is thinking about the systems of systems level.
Yeah.
So each of the pipeline are specifically addressing a certain modules of deployment. Let's say I have one component. I may have combined multiple components into the same pipeline that I can add, because if it's the same technology, same language I'm using it, I may use the same pipeline developing a multiple components. When I integrate that each of components, and basically I'm talking about the system integration or the component integration, then address that each integration faces possible risk. So starting from the bottom up, each of the leaf nodes in the bottom, and try to merge when you go up and up in an application list. If I have a three-tier application like a database and simple business tier and web tier, I may have a different pipeline of the multiple web components and each of the messaging services, an example. So each of these services, they may have their own risk and security controls. Then if I implement that, so I should merge that risk in a production level, like start from system and merge the others and others. So eventually we'll have a whole systems are talking each other. So I see the examples are people are sharing that knowledge in a higher level. So each of the pipeline are creating some artifact and sharing with the higher level or the upstream and sharing the system level, and goes back to the application context. So the concept is heavily used right now. It's kind of old name, but it's applicable right now. Model-based thinking, model-based system engine. It's another long topic we can discuss. Putting a secure knowledge into that concept and try to implement each component. So I see a lot of relative, the mapping with attack trace. If the system level, each of the nodes can be a component in the system, which basically calls a model.
Wonderful. That's great. And with that, I think we've just run out of time. There is much more we can talk about. I wanted to thank Christopher, Sebastian, Simone, Hassan. Thank you very much for your insights, for your input into the discussion today. At this point, I'd like to hand it over to Raquel. And Raquel, if you want to bring us to a close, that would be wonderful.
Absolutely. Well, thank you so much again for another great session. Just to let everybody know, we do have webinars lined up for the next few weeks. So if you're interested in attending any of these, please go to the upcoming events and webinar section of our website to sign up. We hope everybody found this presentation insightful. And again, we'll be providing a link to the recording of this webinar to everyone here via email. Thank you so much for attending today's webinar. Stay well and safe and have a great day.